One of the cool things that we've already seen about natural log curves is the gradient of the curve at its x-intercept of 1 is exactly 1. And this is really reminiscent of the fact that the gradient of y equals e to the x at its y-intercept is also 1. And so we see that symmetry of these two curves because really they're just reflections of each other around that line y equals x. But if we're working with log curves that don't have a base of e, and this one over here is just a generic case, we've given the base the label a there, so it could be anything. Can we come up with a little formula for the gradient of the curve at the x-intercept? Yeah, we can, and we're doing this not so that we've got another formula to remember. You don't have to memorize this result, but it's just interesting to look at it and see that all log curves, no matter what their base, will follow this same pattern. So if we differentiate this, and of course I'm not ready to differentiate it yet, before I do that I need to use the change of base formula to rewrite it as natural logs like this. Now I can differentiate it, and we've seen this result a few times now. We get 1 over x when we differentiate the x part, but this constant comes along for the ride, and it's on the bottom of the fraction. And so we end up with the x down here, and also the natural log of whatever the base was. Now if we want to find the gradient right here where x equals 1, we just sub in x equals 1 and see what we get. Well, if x equals 1, we're just going to leave it out here because we've got 1 multiplied by something. We'll just put that thing, and we've got the natural log of a. So this is a result that pops up for all log curves. Does this log curve meet the criteria? It absolutely does, because here a is just e. So if you have on the bottom here the natural log of e, that's just 1, and that explains why 1 over 1. We get that good result over there of just being nice and simple and being 1. But we can apply this freshly each time using our knowledge. We don't have to memorize it.